So you know that problem that I said, hey, that one's important, was it 45?
Yes.
Okay. The one where I pointed out, I think it was 48, you know, the one that we have to multiply and then take a derivative. That one's important. Writing the equation of a tangent line. Very important. You're probably going to have a tangent line equation problem on every single quiz in Unit 2. Okay? So write it down. Don't start it yet, though. In order to write the equation of a line, we need two things. Shout out one. We need slope. What else do we need? The point. Okay? So, we at least have x equals 2 and we have our function f of x. To find the slope, everyone say it together. To find the slope, we need to find the derivative. Okay, think about it. 6 minus x squared. 6 minus x squared. Caitlin, what would be our derivative? Where do you think it would be?
6 minus 2x.
Colby, do you agree with Caitlin? Why not?
Because a constant is going to go to 0.
Okay. Caitlin, Colby's saying that our constant has a derivative of 0. Okay. We have two differing opinions. Okay. Have a conversation at your pod. Who's right? Okay. The derivative of a constant is 0. You have no idea how common of a mistake that is. Okay? So I just told Caitlin, thank you for making that so that we can talk about it because it is such an easy mistake to make. Okay, 6. Woohoo, 6, you know? Okay? I hope that's something that will stick with you for tomorrow. Okay? It is a very easy mistake to make. So our derivative is negative 2x. Since we want the tangent line at 2, let's find the derivative at 2. Negative 4. Okay. Turner, how do we get the coordinate?
We plug back in our value for f of x.
Okay, so we need f of 2. 6 minus 2 squared would be 2. So our coordinate is 2, 2. Our slope is negative 4. So y minus y equals slope times x minus x. Don't do any more algebra. Leave it like that. That's how I want to grade it.
Oh, okay. No, we get it.
I do want to show you a shortcut on your calculator to where you can check your derivative at a point. Will you please get out your calculator? Okay. You cannot find a derivative on your calculator, but you can evaluate a derivative on your calculator. And I want to show you that so I can tell you so you can check your answers essentially. Okay? So everyone go to the math button. It's right here. And what does number 8 say? Deriv. So math and then click 8. For those of you who have my calculator up here, it should look like this. If you have an 83, it's going to open a parentheses. Okay? For those of you who have my calculator, we're going to put an x. So we have that d dx. We're going to put in our function 6 minus x squared. And then in this little box right here, you need to tell it where you want to evaluate it at. Those of you who have the 83, you have this, n deriv parentheses, right? You would want to put in your function, comma, that you want to take the derivative with respect to x, comma, and then the number you want to evaluate it at. The comma is by the parentheses. Okay, my 83s. Whose doesn't look like this? Whose doesn't look like this? Autumn and Chris and Tegan. Okay. Autumn, Chris, Tegan, did you figure it out? Okay. Awesome. What do we get? -4. Okay, that's a way for you to check yourself. Okay, there will come a time where maybe you'll get to evaluate a derivative on your calculator in a test. Okay, that would be nice. So this is how you would do that. Also, everyone graph 6 minus x squared for me. Yep, turn off your plots. Those of you who are in stats, Zoom 6 gets you back to the 10 by 10 window. Zoom 6 gets you back to normal. The 6 minus x squared, our function. Okay, so here we are at x equals 2. We found the equation of this tangent line right there. I also want to show you that in our graph, we can find the derivative at a point. Okay, do you remember how we talked about in the second calculate menu, we have all these options? Well, one of them is dy dx. So if you go to the second calculate menu and hit 6 for dy dx, you can punch in a number and hit enter, and it'll tell you the derivative at that point as well as the y value. So you can check yourself in both cases. Okay, I'll go through that again. If you press second, the trace menu for second is calculate. Here we are, dy dx. It'll bring this up, and all you have to do is punch in a number and hit enter. It'll tell you the x and y value and the dy dx value. Yes? All right. So it's not something that you're going to get to use like extensively, but something that you can check your work with. Okay? We'll use it more and more as the year goes on. All right? And I'll keep teaching you how to use your calculator in calculus. Okay. We have talked about instantaneous rate of change. We have also, in a previous math class, talked about average rate of change. take 60 seconds at your pod, talk about what you think the difference is between instantaneous rate of change and average rate of change.
Yes, on it.
Okay, as I've come around and kind of eavesdropped on your conversations, instantaneous rate of change, you all agreed that was at 1 point. Okay, and how do you find the instantaneous rate of change? The derivative. Okay. Average rate of change, as I came around, you guys were discussing like multiple points. Okay. Average rate of change, we're still going to have like a set interval, okay? But the average rate of change is going to be over like 2 points instead of 1 point, okay? So I know some of us were describing it as all the points like on a specific interval, okay? So average rate of change, we're still talking about slope because we're still talking about rate of change, but it's our rate of change between 2 points, okay, over an interval. So this is the average slope over this entire interval, and here I'll even like highlight that in green for you. That is the average slope across the interval. Versus instantaneous rate of change would be the slope at 1 point. What? Let's see if I can figure this out. Okay, average rate of change, slope between 2 points, instantaneous rate of change, slope at 1 point. Okay, you guys see all of this and you're like, oh my gosh, but guess what? We have the power rule. You can use the power rule as much as you want to. Okay. So I want to do an example of a problem where we look at both the instantaneous rate of change and the average rate of change. Okay. Instantaneous rate of change, like I said, slope at an individual point. Okay. Average rate of change, slope between 2 points. So I'm going to give you the chance to write down that our function is still 6 minus x squared. Okay, but we're going to find the average rate of change on the interval 2 to 5. I'm going to find the average rate of change on the interval 2 to 5. Okay, So if we're gonna find slope, what do we need? Okay. If we're gonna find the slope between 2 points, we don't actually need the derivative. So instantaneous rate of change, this is when you're going to do the derivative. Okay? Average rate of change, we're actually going to find the y values. So f of 2, 6 minus 4 is 2. F of 5, 6 minus 25 would be negative 19. So our average rate of change is going to be our change in y over change in x. Just the basic algebra 1 slope. Okay, so what do we get there? Huh, yeah. Thank you. Would I count you off if you didn't reduce that? I should. Really, 21 thirds should reduce to 7, but if it was something like, like 22 fourths, if you didn't reduce that, I'm not. Instantaneous rate of change means we're going to take the derivative. Instantaneous rate of change means we're going to take the derivative, which we've already done this, right? We already figured out that our derivative is negative 2x. Okay. So if I wanted the instantaneous rate of change at negative 2, I would plug in negative 2 to our derivative. Raise your hand if you have or are taking physics. Okay. Sometimes we get a mesh, physics and calculus together. Okay. You don't have to be in physics to know what we're talking about. Okay. But for some of you who are in physics, you'll get to see a little overlap today. And then when we get to March, I think we'll do a lot more of it. Okay. What I need you okay. Free falling motion. If I take an object and I drop it, it's modeled by this path. Or this equation. Its path is modeled by this equation. I can either drop something or throw it down with force or throw it up with some velocity. What does G stand for? Gravity. V naught or V sub 0, initial velocity. So this is gravity. Initial velocity. And S naught or S sub 0 is going to be our initial position. How far off the ground are we? Our force due to gravity, we'll use a different number depending on if we are in feet per second squared or meters per second squared. Okay. Let's see, gravity. In feet per second squared would be negative 32. In meters per second squared would be negative 9.8. Okay. All right, watch this. Don't write it down yet. But this is our velocity equation. Don't write it down yet, just look at it. Do you notice anything? Somebody whispered something. Turner, what did you whisper?
It's like the derivative, it's like the t squared
This is the derivative. So guess what, people? You don't have to memorize this velocity equation. If you can set up a position equation, its derivative is velocity. Okay? That is what you should write down. If we have a position equation, we can take the derivative to get the velocity. The instantaneous rate of change as an object changes position over time, change of position over time, velocity. So we're going to go through an example of how to set up an equation like this and what different things we can do with it. Okay? And then that's it for today. A physics book is thrown straight down from the top of a 220-foot building with an initial velocity of 26 feet per second. This person does not like physics. It could be a calculus book. This person really is partial to calculus. No, physics, they're not getting along very well. Okay? So what do we know? 220 feet. What is that? Okay? 26 feet per second. Now, let's talk about this though. If we are throwing something down, then our velocity, it has direction, and so our velocity would be negative because we are throwing something down. If we're throwing something up, okay, that would create a different path for our physics book. Okay, so if we're throwing it up, positive velocity. If we're throwing it down, negative velocity. Okay, so our position equation, 1/2 times gravity. Which gravity are we going to need to use since things are in feet per second? We're going to have to use this gravity. Okay? So gravity times 1/2 would be negative 16. So we have negative 16 t squared. Plus velocity times t, negative 26t because our velocity is negative, plus our initial height. Well, Colby, yes, can we take the derivative? We can take the derivative. What will that tell us? Okay, if I want the velocity equation, we could take the derivative. Colby, since you asked about it, I'll give you the honors of finding the derivative. Negative 32t minus 26. John, is he correct? Awesome. Questions about either of those two equations so far? Okay. What could I ask you? I could ask you, how long does it take the book to reach the ground? So first of all, am I asking you about a position or am I asking you about a velocity? Adrian, what do you think? Position or velocity? Thinking position. Okay, so we would need to use the position equation. Grace W, what would the position of the ground be? 0. So our position at the ground is 0. We have a really gross quadratic that's set equal to 0. If we wanted to solve it, what could be a nice way? I would suggest the quadratic formula here. I don't know if you want to try to waste your time factoring, but you will have your calculator. You will have your calculator. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to get two answers, but only one of them is going to be correct. Okay, you're going to get a negative answer and you're going to get a positive answer. So I want you to kind of think about ahead of time, okay, I need the positive answer. So if we're dividing by a negative number, you're going to want your numerator to be the negative number. Okay, so should we do 26 plus the square root, 26 minus the square root? Practice in your calculator, but you should come up with 2.984 seconds. Okay, so it would be b squared minus 4ac. Okay. If your initial position is 0, you would be able to factor out a t to solve, and that would be way faster. Okay. Please listen. If you're not looking up here, please do. If you don't have an initial position, you would be able to factor out a t and solve it that way. When there is that initial position, that creates the trinomial. Without it, you have a GCF to factor out. Okay. If you're having issues with the quadratic formula, we'll come back and we'll fix it at the end of class. But I want to answer this last question. What will the velocity of the book be when it reaches the ground? So So Yovana, which equation are we dealing with here? Velocity or position? Velocity. It says velocity, right? Okay. When it reaches the ground. Hey, Chris, do we know when it reaches the ground?
Yeah.
Well, we just found, right? So, with the answer that we just found, we can plug that in to the velocity equation up here. Okay. Since our book is falling, when it hits the ground, we should have a negative velocity because it's been falling. And our label would be feet per second. We're traveling a number of feet for so many seconds. Okay, I'll give you these tomorrow. I don't want you to be freaked out about remembering these. Okay? I'll give you gravity tomorrow if needed. What I do want to talk about real quick is your quiz. Okay? You will be expected to do the limit definition of a derivative. Should I smile? Everyone's like playing out their phones and taking it. Thank you. Okay, you will have to do the limit definition of a derivative, and I'll ask you specifically use the limit definition. Okay? Power rule. You'll have to do the power rule. You'll have to do the cosine rule. You'll have to do the sine rule. But I'm not going to ask you like, hey, please do the power rule on this one right here. Like you need to recognize how to rewrite it and take the power rule. Okay? I will ask you to write the equation of a tangent line. I will ask you to find points of horizontal tangency, just like we did this morning. Okay. Average rate of change versus instantaneous rate of change. And then what we just did with our falling object. Okay. The first with the position one, you need to know. But as long as you know that you can take the derivative to get velocity, you wouldn't need to remember anything else. Okay? And like I said, I'll give you gravity. Okay? So we still have 5 minutes of class. So if you have an issue like with the quadratic formula in your calculator, I can help you with that right now. If you have questions over a previous assignment, you can ask somebody at your table or me right now. Or you can get started with this assignment, which I will post my answers to sometime after lunch. Okay.